Okay, so now we're going to try to look for a connection between the direct modeling and just approaching it purely from the equation. All right, so in the beginning I had my 6 cups, and what I'm going to do is I'm going to ask myself, how many thirds are there in 6 cups? So I'll do my partitions, and so that I'm imagining at this point that the serving size is 1/3 cup. There's one of the 3rd cups, feed it to the dog day 1.
Okay, and so if I was to represent what we saw Vince doing here, we have our 6 cups. He divided each of those 6 cups into thirds. And then he asked himself how many thirds are there in 6 cups. And that resulted in us getting 6 times 3, because we see there's 3 groups in 1 cup. So that resulted in an answer of 18.
Great. Then I say to myself, oh, wait a second, it's 2/3. So my serving size is actually doubled.
And in order to represent that, we have our 18 days, and because it's doubled, we have to now half that, and that gets us the solution of 9 days.
And that's exactly what we had when we were repeatedly removing 2/3. We got to 9 days. So how do we put that all algebraically into one equation? Well, we could say, how many thirds are there in 6? And still going to have to deal with that, because this equation has to balance. Well, at some point, we're all going to recognize the reciprocal nature of multiplication and division. And when we look at this, it's easier to say, oh, 6 times 3 is 18. So the thing is that our serving size has doubled from 1/3 to 2/3. So the number of days is going to half. So then we've got 18 divided by 2. And so the final answer is 9. So aside from this, setting up your equations like this, at first, people or students are just going to walk it through in their heads. How many 2/3 are there in 6? Well, I know that there are, how many thirds are in 6? 3 times 6. There are 18 thirds in 6. But my serving size is doubled, so I would need half as many, so that's 9.